Okay guys, before we get started, there's a couple terms and things I want to go over. The apothem, well, if I draw you, let's say, what shape figure is this? 1, 2, 3, 4, 5, 6, 7, 8. Okay, if I draw you an octagon, the apothem, it goes from the center to a side. And it cuts this side into 2 equal parts. So the apothem comes from the center of a figure and touches the side at its midpoint, creating a 90-degree angle. So it's perpendicular to the side. Okay, so that's the apothem. The radius, it comes from the center and it goes to a vertice. So this would be the radius here, and this would be the apothem. Okay, so the radius, if you want to think of it, originates at the center and connects with a vertice. Okay, vertices, if you will, because it can have more than one radii. Okay, so here's our figure, apothem and radius. And then what I'm going to describe really quick is the central angle. So, the central angle, jump back to blue. Okay, to find the central angle, and I'm just going to draw a basic triangle right now, which might make it a little tricky, but to find the central angle, what you do is you take the radius, and you have 2 radius, and you basically are creating a little triangle. So if I were to draw a square, and here's the center, and I were to draw 2 vertices, these 2 areas, this area right here, and this area right here, those would be both be my central angle. And how to find the central angle, you take 360 degrees for the entire circle that goes around the center and divide it by the number of sides. So in this case, I would do 360 and I would divide it by 3 for a triangle. So 360 divided by 3 would be 120. All right, 360 divided by 4 for a square or rectangle, because 4 sides, would be 90 degrees. Okay, so things I want you to think of as we move into these notes here. All right, quick refresh on our trig. Remember, sine is equal to the opposite over the hypotenuse. Cosine is equal to the adjacent over the hypotenuse. And tangent is equal to the opposite over the adjacent. Okay, so let's do a quick refresh of these two. So I've got my googly eyes. This is my opposite, and this is my hypotenuse, right? Directly across from my 90-degree angle. So I know it's so. I'm going to do sine of 40 equals my opposite, which in this case is 12, divided by x. Well, remember when x is on the bottom, these technically switch places. So it's 12 divided by sine 40. But for those of us who might need a little refresh, I'll just go ahead and show you what we do. So I multiply both sides by x so that I get it away from here. And I'm left with x times sine 40 equals 12. But then I have to divide by sine 40 and divide by sine 40. And I'm left with x equals 12 over sine 40. I plug that into my calculator and I get x equals 18.7. Alright, so I know that my hypotenuse is 18.7. It says round to the nearest hundredth, but the notes that I already did are rounded to the 10th, so I'm just going to round to the 10th today. Okay, so moving along, another one would be, this would be my adjacent, and this would be my hypotenuse, right? So that would be cosine 58 equals my adjacent x over my hypotenuse 18. And in that case, I'm left with x, kind of messing up here, x equals cosine 58 times 18, which would give me x equals 9.5. Okay, just as a little refresh, you guys go ahead and do number 3 and 4. All right, so your SOHCAHTOA, your trig functions. And then go ahead and move down here. The formula for the area of a regular polygon. Okay, so we've found areas for lots of things, but not regular polygons yet. Regular means all sides are congruent. So that means if it's a regular pentagon, all 5 sides are the same measure. If it's a regular hexagon, all 6 sides are the same measure. So in order to find the area, it's equal to your apothem, A, times your perimeter divided by 2. Some people write it as 1/2 your apothem times your perimeter. I just like to think of it divided by 2. But A, apothem, what we just talked about, and then perimeter, we all know perimeter is all the sides added together. So when finding the area of a regular pentagon, we create a right triangle. Hence why we are reviewing trig ratios. Squares, hexagons, triangles create special right triangles. And for that, go ahead and think a 30, a 60, and a 90, and a 45, 45, 90. So special right triangles. And I'll just go ahead and draw these over to the side really quick so you guys kind of remember. Oops. Okay, so 30, 60, 90. Across from the 30 is n, across from the 60 is n rad 3, and across from the 90 is 2n. We also have 45, 45, 90, and remember n, n, and n rad 2. across from 45 is n, across from 45 is n, and your hypotenuse is n rad 2. So those shapes create special right triangles. Okay. However, when we don't have special right triangles, we use our trig functions. The sine, or so, ca, cosine, and tangent, so ca, toa. But the steps remain the same. We still take the apothem times the perimeter divided by 2. Okay, first thing you want to do is create a right triangle by drawing the apothem and the radius and half a side. So create a right triangle in your figure, and I'll show you how we do this in a second. By drawing the apothem radius and half a side. Okay, the next thing you want to do is find the measure of the central angle and divide by 2, because that's how we're going to have our 90-degree angle. So find the measure of the central angle and divide by 2. Okay, not too bad, right? Next, use your trig function, so, ca, and toa, to find the apothem and or sides. To find the apothem and or sides. Okay? Remember, this is a video, so any time you need to rewind, you need to pause. It makes it kind of nice. Okay, so let's do one of these together. Okay, so number 5. First thing we're going to do is we're going to find the central angle. We're going to do 360, and we're going to divide it by the total number of sides, which in this case is 5. When we do that, we're going to get 72. So that means that when I do the whole center, 360, and I divide it by 5, this entire angle right here is 72. But I only want half of it. I only want this triangle right here. So that's why I divide it in half. So now I divide it in half and I get 36. So what you're seeing me redo right now is I'm redrawing this triangle right down here. I know that my apothem is perpendicular to my side, right? So I know that my apothem is 10, and now I know that I found my central angle, which was 72, divided it in half to get this angle of 36. So now I'm going to put my googly eyes on it. I could actually, like I've drank too much coffee, I've got the jitters. I have my googly eyes. This is my opposite. This is my adjacent. So I know that it's going to be tangent. And I'm going to do tangent 36 equals my opposite, which is actually the side I'm trying to find, right? So x, over my apothem, which is 10. So I'm going to multiply both sides by 10 to get x by itself. And I end up with 10 times tangent 36 equals x. And x equals 7.3. Okay, So now I know this side right here is 7.3, which means this little bit right here is 7.3. But remember, I need the whole side length, so I've got to double it. I'm going to do 2 times 7.3 and get 14.6. Okay, well now I need my perimeter. I know it has 5 sides, so I'm going to do 5 times 14.6. And I'm going to get approximately 73. And now I can figure out my area, which is going to be your apothem, which is 10, times your perimeter, 73, and then divided by 2. Don't go into these next boxes because I do want you guys to do some of them like I'm doing. And that is going to be 365, it was inches squared. So what did I do? I found my central angle, which was 72. I divided it by 2, which gave me 36. So then I knew my apothem, which is this side going straight down, was 10. I found that angle, which is 36, and I used my trig functions to figure out that that side, or half a side, if you will, was 7.3. I doubled that side length and got 14.6. And then I multiplied it by 5 to find the perimeter, all the sides added together. And I got 73. Then I took my formula for the area, the apothem, times the perimeter divided by 2, and got 365. Okay, let's jump down to, actually let's move over to number 6. Okay, first thing I want to do is find my central angle. So I'm going to count, and I see that this side has 8 sides, or this figure has 8 sides. So I'm going to do 360 divided by 8. I'm going to get 45, and then I'm going to divide it by 2, which is going to give me 22.5. So originally this was 45, and then I cut it in half. And when I cut it in half, I got 22.5. Keep in mind, I also cut in half this side. So instead of 14, it's now 7. Well, I need to figure out what my apothem is, right? Which is technically the side right here that's perpendicular. And then because it's perpendicular to the side, I know it's going to be right here. Okay, so I'm going to put googly eyes on. This is my opposite. This is my adjacent. Oh, so I've got tangent again. And I'm going to do tangent 22.5 equals 7 over x. Well, I know when x is by itself, they simply switch places. So I have x, when x is by itself, when x is on the bottom. So I have x equals 7 over tangent 22.5, which is equal to 16.9. So I now know my apothem is 16.9. I know my perimeter is 14 times 8, which is 112. So now I can find the area of my figure. My area is going to be 16.9 times 112, all divided by 2, and I would get 946.4 meters squared. Okay, let's do one more where it's actually a radius and going to the side. So I'm doing a lot of these with you. I'm probably going to run out of room because I didn't write small enough here. But I basically am drawing in the triangle that I'm going to redraw down here. I know that my radius, which is this, is 7. I technically need my apothem, and I need my side length, right? So I have 2 variables I'm going to need to find. But first things first, it's 360 divided by 8, which we know is 45, and we're going to divide that by 2, and we're going to get 22.5. So I know 22.5 is going to be this angle right here. And, hold on one second. Okay. So, it's up to you what you want to figure out first. But, I'm going to put my googly eyes on. I know this is my hypotenuse. I know that this is my adjacent. And I know that this is my opposite. So, you either need to solve for your adjacent or your opposite first. It's totally up to you. I guess I'm just going to solve for my adjacent and get my apothem first. So I'm going to do adjacent and hypotenuse, which is CA. So cosine 22.5 equals my adjacent, which is y, over my hypotenuse, which is 7. Okay, that is going to be equal to, let me just kind of give myself a little bit more room here. Y is going to be equal to 7 times cosine 22.5, which equals 6.47. Keep in mind, guys, that was this piece, and this is your apothem. Okay, now we need to figure out our side length. Another color I could use. It'll show up. These pens are great, they just don't show up that well. Okay, so now you can use the measure of your apothem, that's fine. But I'm just going to use the side that was given to me, 7, and my opposite, and just make it so. So sine of 22.5 equals my opposite, which is x, over my hypotenuse, 7. So I'm going to have x equals 7 times sine 22.5, and that is going to give me my x, which is equal to 2.68. Okay, so remember, this is only half of a side. So I need to double it. Which is going to be 2 times 2.68. And that'll give me 5.36. So, to find the perimeter, I'm going to multiply it by 8, 5.36. And, oh, I forgot to write that down. And my handy dandy calculator tells me that it's 42.88. So now, to find the area, I'm going to take my apothem, which is up here, right? 6.47. I'm going to multiply it by my perimeter, 42.88, and I'll divide it by 2. And I will get 138.72. Okay, I want you guys to do number 8. All right, so I've done 3 for you, and now you're going to do number 8. Okay. Hopefully you get that. What we're going to do now is the area of a triangle. And it's pretty nice because you can find the area of any triangle using this formula. Let me see if I zoom out a little bit, if you can get a better picture. So the area of a triangle is half the product of the length of two sides and the sine of the included angle. So it looks like this. Area is equal to 1/2 B times C, and then sine of the angle. So let's try it right now. We're going to do these two sides. So 1/2 times 8 times 7, and then sine of that included angle. When you plug that all into your calculator, you should get 25.38. And that's your area. You guys try 12. It shouldn't be too tricky. Right? And you're done. I hope you had a good day, guys. I'll see you next class.